In arithmetic, the range of a set of data is the difference between the largest and smallest values. However, in descriptive statistics, this concept of range has a more complex meaning. The range is the size of the smallest interval which contains all the data and provides an indication of statistical dispersion. It is measured in the same units as the data. Since it only depends on two of the observations, it is most useful in representing the dispersion of small datasets. Independent identically distributed, continuous random variables. For n independent and identically distributed, continuous random variables x1, x2, xn with cumulative distribution function g and probability density function g, the range of the xi is the range of a sample of size n from a population with distribution function g. Distribution, the range has cumulative distribution function. Gumbel notes that the beauty of this formula is completely marred by the fact that, in general, we cannot express g by g, and that the numerical integration is lengthy and tiresome. If the distribution of each xi is limited to the right, then the asymptotic distribution of the range is equal to the asymptotic distribution of the largest value. For more general distributions, the asymptotic distribution can be expressed as a Bessel function. Moments, the mean range is given by where x is the inverse function. In the case where each of the xi has a standard normal distribution, the mean range is given by independent non-identically distributed continuous random variables. For n non-identically distributed independent continuous random variables x1, x2, xn with cumulative distribution functions g1, g2, gn and probability density functions g1, g2, gn. The range has cumulative distribution function independent identically distributed discrete random variables. For n independent and identically distributed discrete random variables x1, x2, xn with cumulative distribution function g and probability mass function g, the range of the xi is the range of a sample of size n from a population with distribution function g. We can assume without loss a generality that the support of each xi is 1, 2, 3, n, where n is a positive integer or infinity. Distribution, the range has probability mass function. Example, if we suppose that g equals 1, n, the discrete uniform distribution for all x, then we find related quantities. The range is a simple function of the sample maximum and minimum, and these are specific examples of order statistics. In particular, the range is a linear function of order statistics, which brings it into the scope of L estimation.